You can hear me all well. Good afternoon. Hope you had a good lunch. And the next session is about back to basics with Spectrum. So when I say back to basics, we are really going to go back to basics and challenge some of the things that we have been discussing in the morning. Obviously, without Spectrum, you can't do any of these things, and we have a lot to talk about. I should thank Professor Rahim Tafazali from 6GIC and Alex for inviting me. My name is Abhay Sumanasena. I chair the UK Spectrum Policy Forum, which is an industry sounding board to Ofcom and the government in the UK. We look at spectrum policy issues, long-term issues from the industry point of view. I also lead policy and regulation practice at Real Wireless, which is an independent advisory firm based in the UK. So two questions we have been asked to debate is about the spectrum models, current spectrum policy management, licensing, sharing, are they fit for purpose? And to meet the demands of future networks and the society. And also, we are going to talk about more on the innovation side and the coexistence of different services and the practices we have and what are the challenges, etc. So I think firstly, to discuss about these regulatory or spectrum management activities, whether they are fit for purpose or to have future proofing in regulation, we need to understand the dynamics of the industry sectors that it regulates, right? Particularly the technology is evolving at a rapid pace. So innovation and continues and accelerate. So keeping up with those innovation, the regulation, keeping up with those innovation is hard. So understanding that environment and the dynamics helps balancing the promoting societal and consumer needs, and also it provides a stable incentive for investing in these future networks. Although it's the connectivity we are focusing on, we also have to think about how the connectivity is delivered, right? Connectivity is what matters to the society and the consumers, but the radio network, access network, the AI interface, which has access to spectrum and how efficient that is, then core networks, and also the other parts of this, how the services that we use, how these services are delivered, the content, also those devices we use, they all are part of this ecosystem. So, so what are the challenges or requirements of future networks like 6G, right? Firstly, we talked about capacity requirements for capacity in the morning, right? Spectrum and spectrum efficiency alone cannot do that, give enough capacity. We have to, in legacy networks, mobile networks are based on macro cell networks, right? But with adding high frequency on top of that requires some kind of densification. Then virtualization gives us, in the past, we had this dedicated hardware, but now we have more flexibility because of the virtualization. Also, the lot of wireless infrastructure is shared. Sharing gives some maybe cost savings to invest further, but it also gives us a challenge from regulatory point of view, challenge in terms of the competition, infrastructure competition, right? The edge computing, bringing everything close to the users, give, again, more flexibility. Then interestingly, recent spectrum innovation enables private and local networks. So we don't really regulate the private networks, but when it connects to public networks, what does it mean? So there's some thinking needs to go there in terms of spectrum management and regulatory point of view. In addition to that, we have international issues, standardization, geopolitics. We really saw lots of those things at the WRC 23 in December. And also the increasing use of satellites, HAPs, and drones, making this connectivity more efficient. So I think I'll pause there. The most importantly, again, back to basics with spectrum. So the important thing is that there's no free spectrum. With 4G, 5G, I think we got most of the low-hanging fruit, the spectrum. Whatever left is really difficult to clear, right? So that's known now. So we need to now think about the sharing and what are the opportunities and what are the challenges with sharing. So when it comes to sharing, the spectrum, the transmission actually doesn't stop at the border, right? So we need to think about the international sense, harmonization, but also when it comes to sharing, we have to think about beyond this mobile world. We have to be, I think there are some satellite industry representation here, but there are broadcasting satellites and other services like Wi-Fi and many other services, and they all need spectrum. So we are, part of that debate. So to answer or debate these questions in the next hour or so, I have great experienced set of speakers. Firstly, I'm going to invite Heidi Himanen from Chief Advisor Traficom. So Heidi is going to look at the progress and update from ITU RSPG point of view on IMT 2030 or 6G and some usage scenarios in Finland.
Okay, thank you. Good afternoon. So my name is Heidi Himmanen. I work as a Chief Advisor at the Finnish Transport and Communications Agency Traficom, who is also the spectrum regulator of Finland. So as we are here in Finland, maybe a few words about where we are today with spectrum. We have 3 operators, 3 MNOs with nationwide coverage for mobile networks. 2G and 4G networks cover more than 99% of the population. And actually the fast 5G networks already cover about 90% of the households in Finland. We have a 3G switch off ongoing and also a government decision that we will keep the 2G networks up running at least until the end of 2029. As you see here, the bands that are allocated for mobile networks today, they are used for a little bit different purposes. The ones in light green, 2.3 gigahertz and 25 gigahertz bands are allocated for local networks. So not only assigned for the big MNOs, but also local spectrum. We have technology neutrality, of course, as in the EU legislation. So all bands can be used for all generations. And also the operators can, of course, use carrier aggregation to optimize the networks and provide as high speeds as possible. We have 5G now in 700 megahertz band and 3.5 gigahertz band, just not so much in the 26 gigahertz band, but it has been assigned to the operators. And 5G can, of course, be implemented in other bands later. Our spectrum policy has been to make the new spectrum quickly into use without fiscal goals. So not paying large amounts of money to the government in spectrum auctions. The it makes the networks cheaper to build, easier to plan. We have less congestion and more capacity. We also have unlimited data in Finland, so you just pay for your subscription. We have quite inexpensive prices and development networks and good coverage. So I think the spectrum policy for mobile networks in Finland has been a great success. And this just to show you that what it means to have the basic coverage of 4G and 5G. So 4G is the dark blue, 5G is the pink color. So on the left-hand side, you have the basic coverage. And on the right-hand side, you have the coverage of the availability of 100 megabits per second. And Finland is the most sparsely populated country within the European Union. So this also the map on the right shows you that. And I think this is also a success that we have this good household coverage due to the fact that we are a sparsely populated country and that we are at the border of the European Union, which sometimes can make the spectrum negotiations a little bit more tricky. So let's go to 6G. The usage scenarios for IMT 2030, I guess you're familiar with this picture. And I have been, actually Finland has been contributing to this work in ITUR. Me and actually Maria, who was the moderator from the last panel, have been involved in this work. And there are actually not so many administrations in Europe that are participating and contributing actively to the work in IMT 2030. It's Finland, Germany, and the UK. So we would welcome more administrations there also. But it's just to emphasize how important 6G is to us. Also, the message I want to say with this picture is that the radio access network and the technical performance requirements and the global vision for what 6G RAN is defined in ITUR and in the Working Party 5D. This is the global vision for 6G and what it means. So for all researchers and developers to build on. And we have a lot of new usage scenarios and also some 5G usage scenarios, and then the overarching aspects. It's very important for when you think about spectrum regulation to understand what are the usage scenarios, and also the regulatory work will build on the use cases and usage scenarios that can be foreseen for 6G. And as discussed in the previous panel, some of them are more obvious, some of them build on 5G, some of them will be further on developed. I mean, we will see in the future what the future will bring. But the discussions on spectrum are ongoing now. I have been a co-chair of the Radio Spectrum Policy Group work on 6G. The Radio Spectrum Policy Group is high-level advisory group to the European Commission on spectrum policy. And we have published an opinion on 5G and 6G in October last year. And these are some of the highlights. It's available online for you to read with a very long annex. But the 5G implementation is ongoing in the pioneer and primary bands. We recognize that we need more dynamic and shared use of spectrum that will increase with the uptake of 6G. We also need spectrum for verticals and local networks, and also this demand will increase with the uptake of 6G. We have recognized that there will arise some additional capacity needs, probably in the 6G era, and these could be met by mid-band spectrum. We have also discuss the role of license-exempt or light license spectrum, and very importantly, the role of non-terrestrial networks. And recognize that we need to do some early recognition of spectrum for 6G. Well, the work will continue. This was the first opinion. And now in the coming work plans for the radio spectrum policy group, we are developing a 6G strategic vision to be published for public consultation by the end of this year and published next year. And we will discuss, well, all the things that was in the previous slide, but also based on the coverage and capacity needs, the use cases and usage scenarios, we have to do some kind of assessment of the spectrum needs and assess if we need also for 6G to develop or to recognize primary and pioneer bands, and should we have some kind of timely coordination for the introduction of 6G in EU and so on. There is another group on the long-term vision for upper 6 GHz band. This is very important for the 6G work. And we are working towards a 6G spectrum roadmap to be published in 2026. And very closely linked to the work related to World Radio Conference, looking towards the next conference in 2027, and also the future use of the TV UHF band in the EU. And finally, a picture of the possible future spectrum for mobile broadband. This is now focusing on the terrestrial part of the IMT system, but not at all to forget about the non-terrestrial networks. The work is in progress in Europe to find solutions for providing or opening up the 3.8 to 4.2 gigahertz band for local networks. This would be the first harmonized band for local networks. It's a tricky job because there are incumbents and other uses to share the spectrum with. And some work on the 40 gigahertz band also, well, not so much interest has been shown towards that band. As you know, from the previous panel, you heard about the discussions about the millimeter wave spectrum and the interest for that. The upper 6 gigahertz band has been identified for IMT. And it doesn't mean that it's assigned for IMT yet in EU. Actually, in the RSPG, we will have a discussion about how it should be used or maybe shared between IMT and wireless LAN, which is one of the, well, there are much of interest also for that towards this spectrum band. And there is some incumbent use already in that band, for example, radio links. If there ever were simple spectrum decisions, they have all been made. We have only difficult decisions ahead of us. The future studies are on the bands that are listed here. And they are studied for the coming World Radio Conferences. Many of you know that there is defense use and there is satellite use in some of these bands, and we need to look into if there are some possibilities for sharing. And also not to forget the very interesting discussion on if the mobile satellite service can use the direct-to-device, can bring direct-to-device services in the mobile bands, in the terrestrial IMT bands. So this is my short introduction. Thank you very much.
Thank you, Haji. So in the morning, we talked a lot about learnings from 5G, and that's exactly what our next speaker is going to focus. So Gerhard Schoentel, the COO of the Virginia Towers. He's going to focus on some success factors of spectrum users in 5G and how lessons learned can be applied to 6G.
Good afternoon. Hope everybody's still awake. It's a pleasure to be with all of you here today in Lapland. I'm going to keep my comments brief so we can have an engaged conversation this afternoon. For those of you who don't know about Virginia Diodes, we're a smaller business, about 125 employees. We're focused on millimeter wave and terahertz test and components. We're in the US about 2.5 hours southwest of Washington, DC. So what have we learned from 5G? What lessons learned can we maybe apply to spectrum going forward? And I'm going to focus on some very specific points here. One, and this is not specific to 5G, but we rarely get the use cases or killer apps correct. And I think that this has been the case in 5G, but one of them that is winning is fixed wireless access, or FWA. And it's using spectrum to bridge the digital divide and to disrupt, at least in the United States, the broadband wireline industry. You can tell this because all of the wireline companies are running ads against the wireless companies that have deployed FWA. In 2023, well over 90% of the broadband ads in the United States were from FWA. And just a little story here, and aside, I'm actually one of those customers. I've been with T-Mobile for the past 2 years using a Nokia Fast Mile CPE. And I did this because DSL was essentially abandoned by the wireline companies. And this is the case not only in the United States, but in other countries around the world. I sit kind of on the edge of a cell, and just with the CPE, getting 2 bars of service, able to get around 50 to 80 megabits per second. But being a technologist and acting like an electrical engineer, I decided to test my RF abilities and recently went out and purchased an external MIMO antenna. And so my daughter Pippa and I spent the better part of a Saturday disassembling or partially disassembling the Nokia CPE, unsnapping the coaxial cables from the PCB, and snapping the new ones back onto the MIMO antenna to see what we could do. During that process, I learned that she's a lot more patient than I am, and that I need to get glasses because, man, those little SMP connectors that are the connectors that go onto the PCB are very small. But at the end of the day, we were able to double that throughput, going up to around 150 megabits per second. So what's the point of the story? FWA works. And it's helping to bridge the digital divide, bring more people to the internet. But we need more in terms of equipment and spectrum. I was just at MWC in Barcelona, and I saw in multiple booths that equipment is definitely coming. But that brings me to the second lesson learned from 5G. And that's when we have a new technology, and for 5G, that was new spectrum millimeter wave. We need to walk before we can run, you know, and I think for millimeter wave, we tried to put it on devices like this, and that was somewhat successful. But for decades, there's been success using millimeter wave in things like transport. So we've been using Ka-band all the way up to E-band for transport for many years. And FWA is a next logical step in that progression for millimeter wave. Fortunately, that millimeter wave spectrum is been purchased and is ready to deploy by the operators. And so, you know, I think we're going to continue to be successful in FWA, but we need more spectrum. And that was seen in Peter's presentation this morning on one of the slides, and showing the needed spectrum for capacity. And we're going to continue to be successful, whether that's 5G, sub-6 and millimeter wave, or as we move to 6G centimeter wave, or possibly later in the 6G deployment into sub-terahertz. I look forward to the conversation. Thank you.
Thank you, Jihad. I'm now going to invite Professor Manisha Ghosh from the University of Notre Dame. She's going to look at some applications in the future that will need spectrum sharing side mainly and coexistence, particularly between government and scientific users.
Thank you very much, and it's a pleasure to be here. I am at the University of Notre Dame, and it's not in France. It's in South Bend, Indiana, about an hour and a half south of Chicago. I'm a professor of electrical engineering there. I'm also the policy outreach director for Spectrum X. Spectrum X is the US's first and so far only National Science Foundation funded Institute for Spectrum Innovations. This is a multi-university center, I don't know, about 40 to 50 researchers. And some of the topics that the researchers are engaged in have to do with spectrum sharing. When people think about spectrum, we focus a lot on the commercial wireless users in the US at least, and I'm sure in many parts of the world. About up to two-thirds of some of the mid-band spectrum is actually allocated for federal applications, which includes DoD, which includes science, which includes applications like weather radar to get better weather predictions. And as we're encroaching with wireless, with commercial wireless on these bands, we're really running into problems. So given the discussions on 6G, one of the things I would like to throw out here for this audience to consider is the idea of 6G being sharing native. So we've heard about 6G being AI native. I personally think that developing 6G as a specification that from day one can operate in shared spectrum as efficiently as it does in exclusively licensed spectrum is increasingly important. Let me tell you why. So we've been doing, as part of my research, we've been doing a lot of work on doing actual measurements of deployed systems. Now in the US, some of you may know there is a band called CBRS. This is a shared band. It sits between two exclusively licensed bands. It's shared with Navy radar. And the sharing between the primary, that's the Navy radar, and the wireless, that has been worked out. You know, we have this, not the elaborate system, but it works, of having a sensor network and databases that inform the commercial wireless systems as to when spectrum is available. What was left up to the deployers to do is figure out secondary sharing. So basically the spectrum, some of it was auctioned, and you had the secondary level of users that were priority access license holders. But then you had the third tier that were what's called GAA, or General Access, Authorized Access. So now you can imagine there's a 20 megahertz bit of spectrum that one operator has used, and these are not MNOs, these are school districts. In fact, in South Bend, talking about digital divide in urban areas, South Bend is an urban area, but during COVID, it became apparent that there were a large percentage of low-income households that didn't have access to internet. So the school district decided to deploy a network using CBRS. The problem is that when you deploy a network in CBRS and say a certain set of channels, and somebody else deploys a network in an adjacent channel, two things need to happen. There was a mention of TDD and synchronization earlier on. There is a bigger problem with TDD when you're trying to deploy it in shared spectrum. The TDD splits, uplink, downlink splits of when you're deploying in shared spectrum have to match. You cannot have one channel trying to do downlink while on an adjacent channel, you're trying to do an uplink. We've done a ton of measurements and shown how bad this can be. And it becomes even worse when you're talking about nationwide networks. So this is a fact which I don't think people recognized as much when 5G was being deployed. 5G has, I don't know, a number of TDD splits, many, many, many. You can have one downlink, 7 uplink, 7 downlink, 1 uplink, all of these various things. But guess what's implemented? There's only one TDD split that can be implemented across the country because all of these 5G operators, their bands are right next to each other. And there's no way that one operator can do a different split from others. So when we talk about verticals, right? In my mind, there's no way that any of those vertical applications other than consumer broadband can be supported in the current way that 5G is specified. This seems to be something that hasn't factored into how 5G as a technology was developed. And so as we look forward into 6G, and if we recognize that a lot of 6G will be used for vertical applications that are not downlink heavy, we have to think about our spectrum policies and how we support an application that's uplink heavy right next to a channel which is downlink heavy. Our current 5G specification doesn't do it at all. So when I talk about sharing, being 6G, being sharing native, that's what I'm talking about. It's not, so when we talk about sharing, we think about co-channel a lot, but it's not just co-channel, it's adjacent channel. What is in the channel next to you matters. When you're a high power cellular system, it's not just what you're doing in your channel, it's what in this channel next to you that matters. There is another need for shared spectrum, and we're seeing that in the US. Again, I'll give the example of CBRS. What we're seeing is that there are applications that CBRS spectrum is being able to serve that are not being served either by Wi-Fi or by exclusively licensed. Let me give you some examples. The example I just mentioned was one of them, where you have a school district that wants to deploy a network to serve their customers. You cannot do that over Wi-Fi. Long-range Wi-Fi just doesn't work. It's not as if that area is not covered by MNOs. It's covered by MNOs. It's too expensive. So you cannot do these kind of services if you have to realize only on these two kind of spectrum accesses. The other kind of applications that are really coming up in the US a lot is things like remote monitoring of oil fields. We've talked a lot about IoT and these vertical use cases. I do not believe that those use cases will materialize over exclusive spectrum. So we have to figure out a way to be able to support some of these vertical applications. Another one is precision agriculture. In the US, there are especially in rural Illinois and rural Indiana, huge thousands of acres of farms. There is no way and there's no reason to expect that an MNO is going to cover every square meter of that farm. So what happens, and this is one of the projects we've been working on, rolling out, is what happens now if you have a precision agriculture application in the middle of a farm where there's no connectivity. What we can do with CBRS spectrum is very easily set up a satellite backhaul, put up a pole, do a CBRS that covers a few miles. You have your application. You don't need coverage 24/7. When you're done with the field, you move that whole contraption somewhere else. In order to be able to do these kind of innovative use cases, we have to think about either shared spectrum or locally licensed spectrum. Now, this actually sits in very well with the kind of spectrum that we are looking at for the future, right? So much, as Heidi mentioned, so much of the WRC bands and other bands are being shared with, say, federal incumbents or others. Very difficult to share two high power outdoor use cases. Very, very difficult. But it's much easier to share if you're trying to share it with something that is lower power, much more focused. And so finally, what I will conclude with is the idea that when we talk about 6G, let's try to separate the technology from the band. Somehow the conversations around 6G always seem to be that it's MNO deployed in exclusively licensed bands. Some of the use cases, the way we use data today, where 80% of the data is being used indoors, does not get served well with that kind of a model. I think, worldwide, we're at this point where we've sort of exhausted, in my mind, the unlicensed and exclusively licensed model of spectrum. And being faced in a spectrum crunch, we have to be more creative. Let's try to look at the shared and all locally licensed spectrum allocations a bit more. Thank you and look forward to questions and discussions.
Thank you, Manisha. Our next speaker is Richard Moore, who's principal at Ofcom, the UK regulator. So Richard is going to look at more flexible sharing mechanisms and some of the real world policy areas he's going to touch.
Thank you, Abhay. right way? Can we have the slides up, please? Thank you. Yes, Richard Moore, Ofcom, the UK telecoms regulator. So we are the spectrum manager and also the regulator looking to get better connectivity for consumers. So this is a subject that's very close to my heart. So today, I'm going to try and explain why we think that our approach to spectrum management for 6G will have to be different from how it has been in previous Gs. Things have changed and there's new challenges associated with our spectrum management. It's been touched on already. We think a solution is more flexible use of that spectrum and more spectrum sharing. So I'll talk about that briefly. And then I'll touch on what we're doing at Ofcom to try and enable that and make that happen. So why are things different in 6G? Two things really. It's diversity and uncertainty. So as we look forward to what we call in Ofcom next generation wireless broadband. So it's not just 6G and 3GPP, it's the future of Wi-Fi, it's the future of some of these proprietary satellite systems. It's anything that delivers high-speed wireless broadband to the end user. And that's what we need to accommodate. And that's what the diversity is going to be on the supply side. And that supply side is not just technology, it's the network architecture, it's the business model, it's the deployment model. And then we've got diversity on the demand side as well. So we have local network requirements. Enterprise requirements are very different from residential requirements. We have a plethora of different use cases that people want to use on different devices, in different locations, with different intensity. And this diversity is actually really good because it brings competition, it brings innovation, ultimately it brings choice and the opportunity to better match the demand to the supply. And this is about, finding supply that meets the demand, not the other way around. And so we think that diversity is a great thing and we're encouraging it, but it has this uncertainty as a spectrum regulator thinking out to 2030. How do we know what the optimal mix is of those technologies on the demand side to match the supply side to match the demand side? What's going to be that optimum mix of spectrum? How do we make that spectrum available and authorize it? And this is why we think we need a solution to spectrum management, which is much more flexible. So the flexibility will sort of counteract that uncertainty. If we can flex that spectrum allocation and to make it match better, we're going to get more out of that spectrum. And then we are going to have the opportunity to deliver more wireless broadband, live with the incumbents, and actually deliver the value that's there without sort of predetermining what the market will be. So that's what we think is really important. And that's why, as Manisha pointed out, we think this designing spectrum sharing into the equipment and having a mindset around spectrum sharing is going to be really important if we're going to get the most out of 6G and other next generation wireless broadband technologies. So I think that's the key message. And this is going to be the difference in 6G. We need to build it in. And we've not heard enough about that today, about beyond the use cases, beyond the AI and all these other applications, how are we going to get that flexibility into the radio layer? So at Ofcom, we've dipped our toe in the water of this subject. So we are offering more flexible access to spectrum. So on the left-hand side here, we do offer a shared access product, which is effectively a local 5G network. So we offer this in the 3.8 to 4.2 gigahertz band. It allows an enterprise or a business to license the spectrum directly from us and deploy their own 5G network. We've been doing that since 2019. We're currently going through the process of modifying that and updating it to make better use of that spectrum. So we're going to propose to increase the power slightly in lower density areas. We're trying to look at the problem that Manisha mentioned about the synchronization, whether we're linked to that synchronization. So that synchronization can limit the density of deployment we have. And we're just encouraging people to talk to each other a bit more to actually get some collaboration within industry, find better ways to use that spectrum. On the millimeter wave, we're working with a technology which wasn't designed to share. And so we're doing our best. So we've recognized the difference in demand between the rural and the urban areas. And therefore, we have different policies around how we make the spectrum available there. And even within urban areas where we see there's going to be more demand, we are going to make differentiate between a local access license and a license that's available to the national MNOs. So that, again, we can have a different combination of networks being deployed, different business models there, so that we can facilitate that. And a very live piece at the moment, and off the back of WRC, we're doing some work there, working with colleagues in Europe to look at whether there are opportunities to do hybrid sharing in the upper 6 gigahertz band, where you might be using Wi-Fi in some locations, mobile in others, maybe it's a geographic split, maybe it's an indoor-outdoor split. So again, trying to encourage the technology to support more flexibility in that equipment. As we look through to 2030 and beyond, we do need to put the consumer at the heart of this. We need to, think about that end user and what they want. They want high quality, high reliability wireless connectivity. And as many people have touched on, as we look at 6G, that's going to be likely be a combination of non-terrestrial networks and terrestrial networks. And that's where we're going to, we've got it as an agenda item in WRC, looking at satellite, doing direct to device within mobile bands. How's that going to work? How's the technology going to flex? How are we going to make sure we're not sterilizing too many bits of the country in order these things can coexist together? We've talked about the small cells operating with the macros. And again, this is just the complexity of getting various wireless broadband technologies working together. But then we need to think about those important incumbent services. We know that in the bands that have been identified for study at WRC, that there's important NATO applications in there. We know space science is going to be increasingly important. We've all talked about sustainability today, and space science, space weather, understanding the environment we're in is never been more important. So we need to protect those applications as well. So when we think about 6G, we shouldn't be assuming that we're going to be able to clear bands as we've done in previous generations. The incumbent use is too important and too hard to move out. We shouldn't be assuming high power. We need to think about variable power transmission, see how that fits in the environment of deployment. And we do need to think about this sharing by design. Final slide, and I'll touch on this quickly. We're doing what we can to experiment and find different ways of sharing. And we think the time's right and the building blocks are there to do some really practical stuff in the field. And so with the software-defined radios we have now, Open RAN, the flexibility in deploying radios, we think there is opportunity for spectrum sandboxing. So we can actually go out there, make measurements in the real world environment on real networks. And so our sponsoring department, the UK government, is now funding 3 projects that will run for the next year around experimenting with different ways to share spectrum between mobile and Wi-Fi, and also between these local networks to see if we can get them closer. And the sort of themes of that are using these radios to understand the radio environment. So looking at the nature of propagation, can we get information that will allow us to improve our propagation models that we rely on heavily for authorizing spectrum at the moment? Can we understand the nature of utilization? Is the spectrum actually being used? Is it available for more use? Can we understand the nature of interference? Are our assumptions about the nature of interference too conservative? Can we tweak that? That data needs to come into some sort of repository. So there's a data transfer and data formatting and data processing issue there. And then we can look at the brain, the authorization brain, whether that's a database, whether it's an AI, whether that's localized or centralized. So are there different ways that we can be authorizing different users to get more out of the spectrum? And the final bits of these projects that we're looking at are then running simulations. So can we run a simulation that would look at the scale of those opportunities across the country? So we can do a limited amount of tests, but does that scale across different environments? Could it apply to different bands as well? And then the economist is going to look at, well, does it really deliver real benefits? We recognize that these more complex systems are more expensive, but what are the opportunities to get more out of this spectrum, this very scarce asset? And so we're really interested to see if there's new ways to do this. And this is all feeding into that pot of looking at new ways as we go forward. So this is a long-term journey. It's a 2030, 2035 journey, but unless we start it, we're never going to get there. So they're my opening remarks. Thank you very much.
Thank you, Richard. So really interesting points there. I think you can now see why when we talk about spectrum, we have to think broad and we have to really go back to basics. And picking up the last point Richard mentioned, Spectrum Sandbox, Real Wireless is actually one of the winners, and we are just initiating that work and look forward to working and doing a lot of experiments on some of those use cases. So I think having heard everything, perhaps I will ask one question from all panelists before giving the floor to you. Maybe let's go back to the original question. If each of you can give a brief comment. So are these current models of spectrum policy and sharing fit for purpose to meet the demands and requirements of future networks and societies? What do you think?
Well, if I start, short answer, no. We need to do some work. We need to do innovations in the spectrum regulation and spectrum management side. And but we also would like to have inputs. I think there is a little bit of a gap between the research and development and innovation and the regulation. So we are happy to also see trials and get some inputs on what is the future on dynamic use of spectrum and sharing of spectrum. And for example, I have been challenging colleagues in the 6G flagship in University of Oulu to try to answer these questions.
Yeah, so I think when we think about the range of spectrum that are available, and we really want to go back to the basics of spectrum, maybe we need to think about how the physics needs to, or the spectrum policy needs to follow the physics. Hopefully everybody remembers AM radio from back in the day, broadcast around a megahertz. And, you know, at those frequencies, you can actually bounce off of different atmospheric layers and get hundreds, if not thousands of miles of transmission. So you could be, say, in St. Louis and get a transmission from Boston. And if you go to the other end of the spectrum, things that are being considered like upper millimeter wave and sub-terahertz, well, we know the range is limited there. And so there are actual physics behind everything in between. A lot of talk about sharing today. You know, I think on a geotype basis, you can share more as the frequency goes higher. And so crafting policies that are specific to the different frequencies, I think, is something that definitely needs to be considered as we move through 5G and into 6G.
Yeah, just to carry on the idea of following the physics. I think there is, among electrical engineers in particular, we think we can use signal processing to fight physics. So millimeter wave, we don't go very far. Okay, we're going to put, make beam forming and get the signal to get to the same range. Yeah, you can do that, but now your beams are so narrow, you've got to track those beams, which become very difficult. And so understanding, where you as signal processing engineers, you let the physics dictate what you do is very important. Along the same lines, I think when we're talking about having different kinds of sharing, I think my personal opinion is I believe there is a severe bar for innovators to come in the wireless field today. The 3GP process is very rigorous. If you have a new idea and a new way of building a wireless network, you either do it in the unlicensed band or you have to push it through 3GPP, where it will most likely die. So creating spectrum spaces for innovators to come in with new ideas, new ways of building networks, new use cases, new verticals. I believe that regulators and technologists really have to pay more attention to that space. And finally, I think we need to pay attention to how we use our networks has changed. When 1G came about, a cellular network was basically meant to service people outdoors. It was supposed to be ubiquitous. It was voice, right? We've moved far away from that, but our basic cellular architecture has not changed. We've gone from maybe macros to micros to some small cells, but fundamentally, we are trying to innovate on a network architecture that does not take into account that 80% of data is indoors, that when people are outdoors, they don't need, gigabits of data or even hundreds of megabits. What they need is guaranteed maybe even 10 or 20 megabits, no matter where you are. We have not been able to deliver that. Sometimes I feel the cellular space, and by the way, since I'm an academic, I can talk to both sides of the equation. I don't have any vested interest in Wi-Fi or cellular. Sometimes I feel that many of the applications I hear about, which are going to be 6G or would have been 5G, can be very well served by Wi-Fi. So understanding how best to use very, very valuable, high power, exclusively licensed spectrum to do what you cannot do with Wi-Fi, or to do something that truly needs that kind of spectrum. I think as a research community in particular, we should be focusing a lot more on those aspects. And I know I said finally, but one more point I'll make about trying to do sharing is we don't have an hand to do sharing well. We need to understand the effect of interference. Today, we don't really have a good way to quantify interference, to report interference, and to react to interference. All of those need to happen to really make dynamic spectrum sharing possible.
Yes, well, I think from my introductory remarks, I was clear on, yeah, things do need to change. From a technology point of view, I think there is, well, from a technology point of view and from a regulation point of view, we continue to use a sort of interference to noise ratio as the thing against which studies are done. And you look at the incumbent services and you look at the incoming services, and generally you're pretty conservative about that. So we are reliant on these propagation models. Many of them have been around a very long time. We're also reliant on, there's an assumption that these things don't, there is constant demand from all the services all the time. But I think having a bit more sophistication around not recognize, going up the stack a bit. So come off that interference to noise ratio and actually come up the stack. And Wi-Fi is, or license exempt is one of the few that do that. You have the listen before talk protocol, and that allows all these different diverse devices to share the same spectrum and perform pretty well. I think as we look at these sharing studies, and again, particularly in this time round, when we look at the bands that have been identified for study for IMT, we know that some of those incumbent services aren't going to be coming out, and therefore we are going to have to look at how we get the best out of that spectrum for the next generation of mobile technology. So I think there's work to be done on both on the regulation side, but also the technology needs to work with that to get the best out of it.
Okay, so I got a list of really difficult questions, but I'm going to pause that, put that away, and give you the floor because we've been talking a lot now. Please, someone.
Dean Bobley. Thanks for that panel. I agreed with lots of what everyone had to say. One aspect of spectrum sharing, everyone seems to talk about spectrum sharing, but there's an aspect that hasn't cropped up yet, which is around time. If you're a utility company wanting long, thin networks for your power lines, you probably want to have a decades-long spectrum sharing arrangement. But if you're trying to do something for an event, it might be a day. And if you're trying to have, I don't know, manage peaks and troughs in usage in a busy part of a city, it could be on minutes or even seconds. Are we ever going to be able to get spectrum sharing frameworks that go from a second to 30 years, or are we going to need a number of different approaches?
I think all of those are very valid and models of sharing. And my personal opinion is we have to have different models for different kinds of applications. So looking at how Wi-Fi shares, for example, that is at the millisecond second level. Yeah, and it's a distributed system. It works. Yes, you don't have quality of service guarantees, but your applications that you run over that tries to live with it, and having more spectrum alleviates some of those problems. The more spectrum you have, the better you can do listen before talk and share spectrum. The 30-year guarantees, so that is a perfect example of spectrum sharing that was adopted in the US and 6 gigahertz. Basically, all of the incumbents stayed exactly what they're doing, exactly what they're doing, and you just do this underlay of low power unlicensed underneath them, and you've suddenly opened up a whole new different use case that can coexist very well with these mostly point-to-point outdoor links. As we look to newer bands and newer applications, we have to, I think we have to be creative. I know it's nice to say we can have one framework and fit every band into it, I personally think that that's really going to be hard and maybe not the best approach. We have a suite of tools. Let's pick the right ones for the band and the use cases that we are trying to, sort of make coexist in a particular frequency.
Right. Yeah, please go ahead.
Tatu Koljonen, Aalto-yliopisto, Aalto University. So, two-faced question. So, in the past, we have had unlicensed and licensed bands, but there is, of course, between there could be some spectrum exchange or tokenization and blockchains or some variants of this licensing that we have good examples from CO2 exchanges and so forth. Are those in your list of solutions? Of course, when AI is in the physical layer, as Nokia showed this morning, that it's we can optimize every waveform for every bit, and it should be relatively easy to utilize the spectrum effectively. But I also comment this question of or claim that we should disconnect the Gs from the spectrum bands. I claim that this would be the end of Gs, because the Gs are exactly for that purpose, that we get the bands. And is that something that would undermine the ecosystem building or emergence of innovation ecosystem or business ecosystem around 6G? Because we don't have a credible business, a guaranteed business case necessarily. If we have the bands, we have the guaranteed business case.
Yeah,
Anyone wants?
I can take
Please go
that.
ahead.
Go ahead.
I can, yeah. So first, I think you asked about the light licensing. So yes, we have currently we utilize license exempt, and then we have the license bands. And actually, Finland was proposing for this 57 to 66 gigahertz band that we would try out some light licensing in Europe. But well, it wasn't so that we didn't get so much support. I think there is a need for some kind of light licensing if you want to build a 5G, 6G network in a kind of unlicensed band, but you want to have some kind of protection from this. So we see this. We see some use for this, but it hasn't been reality yet. But actually, we proposed that in the ECC work. And then I forgot the second question.
So, depending on your question about, whether if you don't have exclusively licensed band, is there a business case? To me, there are two different. So if you're an operator, yeah, but if you're an equipment provider and you're 5G, so for example, in the US, people are deploying 4G and 5G in CBRS. It's a shared band. So as an equipment provider, if you're making equipment, the more bands you have available for your equipment to deploy in, the better, I would think. I do agree that if you're an MNO and your business relies on having exclusively licensed spectrum, that is going to be something you are going to be concerned about. But on the other hand, what we've seen again with CBRS in the US, Verizon is an MNO. They have C-band, which is exclusively licensed, but they're also deploying in CBRS. And when they need it, they are aggregating these unlicensed or license exempt bands along with the exclusively licensed band to get better coverage, better throughput, better hotspot coverage. So I think going beyond this idea that the only way to get for MNOs to operate is an exclusively licensed spectrum, it's to me, it's limiting by actually, and especially now, if you combine it with Open RAN and the flexibility that allows you, why can you not aggregate unlicensed bands, license exempt bands, and exclusively licensed bands? And actually, you have now a much better network than if you were trying solely to get exclusively licensed bands.
Yeah, I'll just add to that. I think the lady from DT was talking earlier about operators in the future may be having to pull together these different types of connectivity. So whether it's bringing a satellite layer in against their terrestrial layer, maybe sometimes they do offload it either into Wi-Fi or into unlicensed new radio. And so I don't see the link between, if there's no guaranteed spectrum in the pipeline, there can't be 6G and there can't be a future. On the light license point, I think one of the things that we found in looking at sort of dynamic spectrum access, I think most providers, even if it's a small wireless ISP, they want some sort of guaranteed layer. And then if there's then some sort of bonus capacity, or even potentially 95% of the time, they can get the additional capacity to service their customers, but they've got this fallback guaranteed layer. So I think that's something we do see in the market, that people don't want this sort of complete uncertainty that thing might just stop, but that more opportunist ability, and maybe that touches on Dean's point about being able to get bits from one place to the other when you need to, but maybe via different routes at different times. So maybe you get that resilience and that diversity through having different routes through the network.
Okay, thank you. So the next question is here.
Actually,
Can
I
I
have the
also,
mic.
while
So-
moving the mic, can I add a comment, please? So when you ask questions, can you make it brief and clear questions so you get more likely of getting an answer? So please go ahead.
So I have the mic. So my name is Matti Latuho, 6G Flagship. One comment first to Heidi about the lack of innovation and research on spectrum-related matters in recent years in Europe. That is absolutely true. But academic research community goes after the research program open calls. We haven't had for 15 years any spectrum-oriented research calls machinated by European Commission, which is a big problem. Now we have to look at what has happened in the US all this time, all these years. They have been having lots of interesting spectrum innovation competitions, etc., machinated by DARPA and NSF and many others. So it's lack of funding opportunities for academic research community in Europe, and something should be probably done about that, and fast. Now my question is actually to you as panelists. Last November, US White House announced establishing this national spectrum strategy process to try to force FCC and NTIA to work more closely together, plus something else. Could you give us a short status update? What's going on and what can we expect in the coming months from that?
Sure. So the National Spectrum Strategy came out in November. And following that, about a month ago in March, there was a National Spectrum Strategy Implementation Plan, which set out very concrete steps that would be followed over the next two to 2.5 years to accomplish some of the goals, right? So the main things that came out of that implementation plan is there were 5 bands that were identified in the strategy. One was the lower 3 gigahertz, which is a big issue in the US, not so much in the rest of the world. The 7 to 8 gigahertz band, which is, I think, a worldwide concern at this point. The 5 gigahertz, a small band just for UAS networks, 18 gigahertz and 37 gigahertz. The main bands that I think both FCC and NTIA are focusing on in the near term are the lower 3 and the 7 gigahertz. And the processes there for the lower 3, which is really sharing with federal incumbents, DoD incumbents mostly, is coming up with studies and frameworks, both theoretical and experimental, to investigate how and if 5G, right now we're looking at 5G, but it can extend to 6G, is how 5G can actually share that band with these incumbents. It's not easy process. There are many, many ways that one can do sharing, and a lot of those will be examined by NTIA, by academia, and by other research efforts. So next few months, hopefully we'll see a rollout of more concrete actions. some of the activities that we've already started, say in Spectrum X, is to look at one aspect, which is, can we even find out how much these bands are being used? So we didn't talk about spectrum measurements or spectrum sensing, but one of the key ideas about whether you can share a band is to figure out how much is it being used in the first place. And a lot of the federal bands in particular, at least in the US, it's very, very hard to find out that information. So there is an effort, there are efforts underway to do that piece, let's sense. Other one is to look at different kinds of sharing modalities. Can we share these bands indoors at low power with very little effort? What does it take to share it outdoors with high power? What does it take to share outdoors with medium power? So there's a lot of work that still needs to be done, but I think we're going to be kind of focused on a few specific bands.
Thank you. And there's a question here and then. So the one. Short
Thank
question,
you.
please.
I'm really happy to see so many panelists coming from spectrum-related regulatory bodies here. So my question is relevant from a regulatory point of view. We're talking about 6G for the society. And in the previous panel discussion, we talked about the business models. And one of the questions that was going through my mind is, what if the governments did not charge for spectrum? They gave it out for free. To the you license it, but don't raise any revenue from it when you give it out to the operators or to the service providers. Just give it for free. What it might do is, this is just a thought, maybe I'm wrong, to bring down the cost of the service low. It will make it affordable to people also. But you license it because you need to control who's using what part of spectrum because of interference and so on and so forth. But the government should not be making money from it because the electromagnetic waves is given free in nature. So I would be interested to hear out from the regulators, why aren't they willing to take a revolutionary stand and say, I'll give it out for free to the society, to the operators, because it will bring more players, more competition. It will help the public in general. And a good analogy of this is, I was reading, if you look at when these countries are small, like Luxembourg and Malta, they offer public transport for free in their cities. It's totally free. You take bus, you take metro. Why? Because they don't want cars. They don't want pollution. And similarly, in Australia, there is in Adelaide, Melbourne, Sydney, in central part, the metro is completely free. So why can't we take the step and give it out this license ban for free? That will be a question.
I can start.
Listen.
Yeah. So if we talk about the mobile spectrum, what we did in Finland was actually that there were not specified fiscal goals in the auctions, in the spectrum auctions. Well, you can see if you look at online, you can see the spectrum fees that were paid in these auctions were not so high. The annual fees that we collect as Traficom, as a spectrum authority, is just to cover our own costs. So it's actually, we have low prices, and that has been, I think, to some parts invested back in the network, but that's why we have good networks. So I think we are kind of close to what you're trying to describe, yeah.
And also, I think Richard might want to come back on this, but when there's so much demand, there's what's the most efficient way of assigning that?
Yeah, I mean, there's a conference there, isn't there? It's a mechanism. Spectrum pricing is a mechanism for allocating a scarce resource, and that's why we use it. If there isn't excess demand, we charge administrative pricing. So we don't charge to make a profit on spectrum. We do it for the spectrum to go into the hands of those operators that are going to use it most efficiently, and they value it most. So that's the very short answer. it's a question that comes up. We've published in documents. If you hook up afterwards, I can point you towards a document that we published recently on spectrum pricing and the rationale for doing it. So we can take that offline if you want.
Just a short question, Heidi. Who is taking the voice of Africa? I mean, we don't have Africa in the panel, and we know that like spectrum issues in Africa, especially for connecting the unconnected, is a completely open issue. Any ideas from there, or are you at the 700 megahertz, reserving space for connecting schools and communities? Something like a public service of the digital public infrastructure discussed by ITU and UNICEF and so on?
I don't have an answer to that. I don't know what the spectrum policy is in each African nation. At WRC, as I understand it, there was moves there to allocate the UHF band to make it available for mobile if that was required. I think there is a point there that chimes with what I was saying about diversity on the supply side and the demand side. And even within the UK, for example, we might see a lot of diversity on both sides there, and therefore a lot of complexity in terms of the optimal spectrum management. But as we think about the technologies, if these are going to be global standards, then the technology's got to suit all those different use cases around the world as well, from income to topography to local politics as well. So I think it drives to the fact that we do need technical solutions which have that flexibility. So whether it's by band or whether it's a greater share to satellite compared to terrestrial. So I think this drives us to, if we are to reach the unconnected 2 billion, 2.5 billion who don't have good wireless connectivity at all, we are going to find solutions which are going to cost in and then can reach those particular use cases. And maybe some of those solutions will find their way into into Europe and into the West, where whilst coverage and quality is pretty good, there are still gaps where the technology hasn't found a solution. So maybe it's an opportunity to, there's still a big market out there to be had if you can get your technology working.
I think I can add a little bit on that. Real Wireless, my company, we've done a lot of work helping some of the regulators. They have different set of challenges. It's so digital switchover is way behind in most of the countries. Therefore, 700 is nowhere near, and also the assignment mechanisms quite different, sometimes very challenging. Some countries never had auctions or some mechanism. So there's additional set of challenges assigning spectrum as well in those countries. But let's stop there. Any other questions before the next question comes? Because we are talking about this 6G symposium, I would like to get the panel's attention to one of the agenda items of WRC 27 in 4 years, agenda item 1.7 relates to the studies or the spectrum bands for, let's say, not really 6G, but IMT 2030 or so future technologies, right? So the 3 bands currently selected was 4.4 to 4.8 gigahertz, 712.5 to 8.4, so 8,400 megahertz, 14.8 to 15.35. So most of these bands are NATO or the military bands, or currently being used by the military. Quite heavy incumbents and very difficult to clear. So now coming back to sharing discussion. So sharing with military it's even more difficult, because you don't actually, as mobile operator or user, if we know who we are going to share with, it's easy to come up with some mechanisms, protocol level or some way to manage that sharing. But if you don't know your the military usage is classified, so we don't know where they are used and how they are used, and so now developing frameworks for sharing is even more challenging. So how can we? These are the 3 bands selected for study, and they are not easy. So what can we do?
Well, obviously, I don't have a clear answer, because that's the work that we are doing towards WRC 2027. But I mean, we need to challenge the way we think about spectrum and spectrum allocations. I think what was built in your question is that we need to somehow define this is for terrestrial, and if we just discuss 6G, I think what came up here is 6G is in the interest of the defense. 6G will be delivered perhaps through satellite, and it can be through terrestrial networks. So if we think about it this way, we might find some ways forward. We need to reset our minds. Of course, I want to also say that in the 4.4 to 4.8 gigahertz band, there are some very important, also from the Finnish industry interest, important Earth exploration satellite. And of course, that is some bands that should be protected. But if I talk about the satellite telecommunication, that might also be 6G in the future.
Yeah, so following on the kind of the security aspect of military communications, for a long time, militaries look for inherently secure type technologies. Well, certainly the higher you go up in frequency, the propagation is not as far as the lower frequencies. And so I think it's natural for the wants of the centimeter wave bands, both in the commercial and defense. But there is a lot of work going on in millimeter wave communications for the defense applications, specifically because that security, inherently secure type of situation.
Yeah, so actually in the US, the 7 to 8 gigahertz band is not only military, it's a federal band, but there are things like GPS, there are radars, there is some earth sensing satellites. So all of it makes it all the harder to share or clear. The one thing which, and going back to the question about NTIA versus FCC in the US, one of the things that we're still trying to figure out is to really get accurate information on usage versus allocation. So the bands have been allocated does not mean that they're actually being used everywhere all the time. So even if you have a sense of where bands are used, you can figure out how they can be shared, which has been done. I mean, even in the lower 3.45 to 3.55 was a federal band in the US before it was auctioned for 5G. But there are still parts of the country where the operator has to coordinate with the DoD before they can deploy. And so as we look towards these newer bands, more and more of that kind of usage will come about. And the initial knee-jerk reaction from both sides is this is too difficult, or we don't want to do this. But as it's becoming clear that both sides stand to gain, actually, because the military is also leveraging so much of 5G technology and hope to leverage 6G, figuring out how you can share information without compromising national security. Those are some of the research challenges that I think, the researchers in the community are looking at with a lot of interest. So there's very interesting research in all of those sharing.
The military needs the bandwidth of 5G and possibly 6G
Exactly.
for operational type considerations. Think an airplane controlling a mass of drones up in the sky someplace for maybe tactical drones, tactical warfighting drones. That does not come cheap in terms of the data rates that are needed for that type of thing.
Okay, so being shown not the red card yet, but so I can take one more question before we summarize. One final question. Okay, so perhaps if we now think about summarizing, I think a really interesting and different point of view, and we really came back to the Earth and basics, right? So Heiji, you mentioned simple spectrum discussions, and that's what the key thing I got from your speech, right? And what is it, how do we simplify all these regulatory procedures and 3GPP process and all those things? How do we simplify? And then Jad, I heard from you, it's not just about getting spectrum, but also we need to be clever about using it right way. So FWA, you said, is the right or next steps to for millimeter wave. So we need to think about using them cleverly, right? So that's an important, interesting point. Monisha, I think you mentioned about developing this mindset in 6G, so geared towards sharing from day one, embedded into the standards, and that's one of the interesting point I heard from you. And Richard, you talked about so there are incumbents, we need to think about them, mindful, and also 6G is more broadly, it's anything that provides high speed connectivity. So we separate the technology and the bands in a way. So these are some thoughts I got, but perhaps you could add your own thoughts and summarize very briefly what we think about the session.
Well, yes. Well, thank you if you thought that was the message of my my presentation, because I'm happy to be able to bring a message that is not too complicated. But the one point I said about that the simple discussions on spectrum are over. We have difficult discussions on spectrum in the future, and but that we must change the mindset and sharing. I like the idea of built-in sharing by design that was discussed here, and that's the kind of mindset that we need to keep.
Yeah.
Yeah, I mean, I'll just double down on we can think of what the applications are going to be going forward, but we don't know how that technology is going to evolve and where it's going to fit in. And so developing technologies that work across all the different spectra that we're talking about today, I think is definitely the way to go.
Yeah, the only thing I would add to the excellent summary you did is actually teeing off on what somebody said, where I actually think 6G should be the last G, in the sense that you build it to be flexible enough so that it can be future-proof. So a lot more programmability, adaptability, software, so that new spectrum bands, new sharing mechanisms, new use cases can seamlessly integrate into an infrastructure that does not have to be ripped out every 20 years or so to make way for new infrastructure.
Yeah, maybe building on that point, that we assume it's more spectrums required to get you on XG, but there's a lot of spectrum out there now allocated to mobile. So finding the cost-effective way to upgrade the 4G networks to 6G, bring 5G through to 6G, and do that in a way which you don't have to have necessarily a dedicated band for the 6G to do that, or a parking band for 6G to transition. So I think making sure that we can find ways to seamlessly migrate the networks up to the next generation, and recognizing that the operators don't want to be doing a rip and replace for a G. So.
Okay, so I think that's all we have, and please give them a big round of applause.